Hello world, Liu here, and today let's take a look at what every single punctuation does in Python. If you're new here, my name is Liu. I'm a software engineer from Singapore, and I make stuff that younger me would have wanted to see. Now back to the video. So first on this list, we have our backtick. So in Python, the backtick doesn't actually do anything. And legend says that this is the case because it is too similar to our single quote. So let's move on to the next one. And next, we have our tilde, which is this twirly thing over here. So in Python, this is known as the bitwise NOT operator. So let's say I have a number. So x is equals to 4, and if I print tilde x, I'm going to flip it. And now it's going to become minus 5. So let's say I have 100. So if I flip it, it's going to become minus 100. And let's say I have 100,000. And if I flip it, it's going to become minus 100,001. And next, we have our exclamation mark. So on its own, it does not do anything. But when we do this, if x is not equals to apple, we print x does not equals apple. So here, the exclamation mark combined with our equal sign will be the inequality operator. And next, we have our @ sign. So our main usage is in decorators. So I'm going to define a hello name, and I'm going to return hello plus name. So this is a normal function, and let's say that I want to change the way that this function behaves without changing the source code. So I can do this using a decorator. So add decorator. So this is how we will do it. So decorator is actually a function which we must define. So define decorator, and it must take in a function, and it must return another function. So inside this function, I'm going to define another function. So define wrapper. And this function will take in the same thing as whatever function that we are going to decorate. So return func name, and we do whatever change we need to do here. So here, let's say that we want our decorator to add an exclamation mark after our return value. So let's rename this at exclamation. And similarly, let's do it here too. So what we do is we add an exclamation mark here, and we return wrapper. And if we call a function now, so hello, let's say Tom, and let's run this, we will get hello Tom with an exclamation mark. So here, this is exactly the same as doing this. So hello is equals to add exclamation, and it takes in hello. So this is the exact same as adding the @ sign. So if I run this again, I'll get the same thing. And next on our list, we have the hash. So the hash is used to write comments. So here, this is a comment and is ignored by Python. So that's it. And next on our list, we have the $sign. The $sign doesn't actually do anything in Python. And next, we have the percentage. So we are probably familiar with this as the modulo operator. So let's say we print 10 modulo 3. So what's happening here is that this will print 1. And this will print 1 because 1 is the remainder when we divide 10 by 3. So let's say we divide 11 by 3, we will get 2. And if we divide 12 by 3, we will get 0. However, the percentage sign can also be used to format strings in Python. So here, let's comment this out. And let's say I have x is equals to 5 and y is equals to 6. And then I'm going to print a string. So x is something and y is something. So right now, I'm going to add this something. So it's going to be a percentage %s, and this is going to be a percentage %s. And I'm going to do this. So percentage and tuple x and y. So what happens here is that the first thing in the tuple will be formatted as the first thing over here. And the second thing in the tuple will be formatted to the second thing over here. So let's run this. And we'll have x is 5 and y is 6. Next, we have the caret. So this caret is a bitwise exclusive OR, which is also known as XOR. So here I'm going to create two binary numbers. So 0B. So I'm going to print binary of A XOR B. So I'm going to get 111100. So here, if we take a look at these 8 bits, the ones that are different will be converted into 1, and the ones that are same will be converted into 0. So in the first two spaces, both A and B have 1, so it becomes 0. And in the next 4 spaces, A and B are different, so they become 1. and in the last two spaces, they are the same, so it becomes 0. That's why we have 0, 0, 1, 1, 1, 1, 0, 0. However, the first two zeros are taken away automatically. That's why we have 1, 1, 1, 1, 0, 0. And next, we have the AND sign, which is also known as the ampersand. So here, this is the bitwise AND operator. And if I print A ampersand B, I'm going to get 1, 1, 0, 0, 0, 0, 0, 0. So let's bin this, and let's run this, and we'll get 1, 1, 0, 0, 0, 0, 0, 0. So here, what's happening is that only if both A and B are 1, will our result become 1. So if even one of them is a 0, it will automatically become a 0. So in this case, only in the first two bits do both A and B have 1. Otherwise, the next two bits, this is 1, 1, but this is 0, 0. And here we this is 0, 0, but this is 1, 1. And here this is both 0, 0 and 0, 0. And as such, our final number is going to be 1, 1, 0, 0, 0, 0, 0, 0. And next, we have the asterisk or star. So as we are all familiar with, the asterisk is the multiplication operator. So let's say 4 times 5, and we are just going to get 20. And here we have it. And here we can also do string and integer multiplication. So 4 times apple, and we are going to get 4 apples in a row. So apple, 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 apple. However, we can also use this asterisk to unpack tuples. So here, let's say I have a list of numbers 4, 5, 6, 7, 8, 9. And let's say I want to assign a bunch of stuff to this. So A, comma, B, comma, star, others is equals to 4, 5, 6, 7, 8, 9. So what's going to happen here if I print A and B is that A and B are going to be assigned to the first two things in the list. So if I print this, I'm going to get 4 and 5. However, if I print others, I'm going to get 6, 7, 8, 9. So what's happening here is because of the star, others will catch everything else in the list. So let's comment this out. And using a star, we can also allow a function to take in any number of positional arguments. So define pi, and here I'm going to have star args. So I'm just going to print args, and let's see what happens. So here I'm going to do high, and I'm not going to pass in anything. So it takes in 0 arguments now. So if I print, I'm going to get nothing. However, let's say I put a 4 here, I'm going to get 4. And if I add more stuff here, let's say 5, I'm going to get 4 and 5. If I add, let's say 6, 7, 8, 9, I'm going to get 4, 5, 6, 7, 8, 9. So what happens here is that whatever arguments that we pass into high will get caught in a tuple called args. And next, with 2 stars, we can make a function taking an infinite number of keyword arguments. So keyword arguments. So I'm just going to print quarks. So let's do this, high. And here we're just going to get an empty dictionary. So here let's pass in a bunch of keyword arguments. So A is equals to 4, B is equals to 5. And if I run this, I'm going to get a dictionary containing A and B. And here we have it, A is 4 and B is 5. So if I pass in more stuff, C is equals to apple, D is equals to pear, and whatever, I'm going to get all of them inside the dictionary called quarks. And last but not least, we can import everything from another file. Let's say from out import star. So what's happening here is that we look at out.py, which is this file over here, and we import everything from out.py. Next, we have our open and close brackets. So here, the one that we are most familiar with is probably defining and using functions. So here, let's say I define a function. So add 10. So here, I need to have bracket. If not, it will be a syntax error. So add 10 to x, and let's say I just return x plus 10. So this is defining in a function. However, when calling the function, I also need my brackets. Y is equals to add 10, 7. So here, after my function name, I must have an open and close bracket. And only then I can call my function. Other than this, we can also use brackets to create tuples. So A is equals to 1, 2, 3. So let's print A and the type of A. And if you do this, we'll get a tuple. So here, if you're not familiar with tuples, a tuple is simply a list that cannot be changed. It is an immutable list. So let's comment this out. And aside from this, we can also use brackets to group stuff together. So let's say x is equals to 1 plus 2 times 3 plus 4 times 5. So I'm going to print x, and let's run this and see what I get. And this is going to be 27. However, using the bracket, I can group these two together, and 1 plus 2 will execute before 2 times 3. So if I run this again, I'm going to get 29. And let's say I put a bracket here, and this changes things once again. And next on our list, we have our curly brackets. So the one that we are most familiar with is probably to define dictionaries. So D is equals to dictionary, and let's say apple is 4, pear is 5, orange is 6 or something. And we normally use curly brackets to define our dictionary. Additionally, we can define sets. So this is going to be a dictionary, but we do not have this key value pair. So instead, we just have one single value. So this is going to be apple, orange, pear. So this is a dictionary and this is a set, and they both use the curly brackets. So aside from this, we can also use curly brackets in our f strings. So let's say name is equals to Tom and age is equals to 30. And next we want to print a f string. So here I'm going to have this name is equals to open and close curly bracket name, and age is equals to open and close curly bracket, and then we have age. So what's happening here is that when we use the curly brackets in an f string, this name will refer to the variable name. So if I print this, it's going to be name is Tom and age is 30. And here we have it. And next on this list is our square brackets. So the one that we are probably most familiar with is to define list. So x is equals to a list containing, let's say, 4, 5, and 6. And if we print x and the type of x, we are just going to get list. So aside from this, we can also use list to index stuff. So I have a list is apple, orange, pear, and let's say I have a dictionary is equals to apple pie is, I don't know, $4, orange juice is going to be $5. So if I print list 0, and over here notice that I use my square brackets to index 0, and in this case I'm going to get apple. Oops, spell wrong. So in this case I'm going to get apple. So if I index, let's say 1, I move on to the next one, I'm going to get orange. And similarly for our dictionary, I need to pass in the key rather than a number. So apple, pie, and I'm going to get the value. And next we have the minus sign. So very simply, we simply use the minus sign to do subtraction. So 5 minus 3 is going to be 2. Additionally, we also can use it to create negative numbers. So negative 100. So if we do this, we'll get negative 100. And next we have the underscore. So here the underscore is the only character here that can be inside a variable name. So I can actually do this. Underscore is equals to hello. And if I print underscore, I'm going to get hello. So here we often use underscore as a variable name to denote that this variable will likely not be used at all. And next we probably have the most important punctuation here, the equal sign. So here the equal sign is the assignment operator, and it assigns a variable to a value. So x is equals to 4, let's say y is equals to apple pie, and z is equals to orange. So here what happens is that the variable x is assigned to the integer value 4, the variable y is assigned to the string value apple pie, and the variable z is assigned to the string value orange. And also the equal sign can be combined with other operators to get compound assignment operators. So let's start with integer x equals to 10, and here x plus equals to 1. So if I print x, I'm going to get 11. And here we have it 11. So here this is the same as x is equals to x plus 1. Or we add 1 to x. So if we do it a second time, so here we add 1 to x 2 times. So we are going to get 12. And aside from this, we can also use the double equal sign as the comparison operator. So let's say x is equals to apple, and we want to check if x is actually equals to apple. So if x equals to apple, so notice that I use double equal sign here, and we print. So if we run this, we are going to get x is in fact apple. And next on this list, we have the plus sign. So simply we use the plus sign to add things. So 4 plus 5, and we'll get 9. And let's say we add string, so apple plus pie, and we'll get apple pie. So we can also do this with list. So let's say 1, 2, 3 plus 4, 5, 6. So if we do this, we'll get 1, 2, 3, 4, 5, 6. And next on this list, we have the slash. So the one that we are probably familiar with is the division operators. So first, let's start with true division. So let's say 5 divided by 3, we are just going to get 1.6777, and here we have it. But if we replace this with a double slash, this is the floor division. So let me just write it here first. So this is true division, and this is going to be floor division. So floor division will always return a integer. So instead of 1.666667, we are just going to get 1. And next we have the backslash. So the one that we are probably familiar with is to use the backslash as an escape character. So let's print hello world, but instead of space, let's say we want to have a new line. So we have a backslash n. So this backslash n is an escape character, and if we print this, we'll get a new line instead of backslash n itself. And here we have it. So there are other escape characters too, such as tab, and if we do this, we'll have a longer space in between them. And let's say if we want to print the backslash character on its own, we have to make it escape itself. So backslash, backslash. So if I run this, I'm going to get 2 backslashes, because this will backslash the next one, and this one will backslash the next one. So aside from this, we can also use the backslash character to split a long line of code into multiple lines to make things look neater. So here, let's say x is equals to 1 plus 2 plus. So here, if this is too long for you, we can actually do this. So backslash, and we move this to the next line. And here we can also backslash and move this to the next line. So if I print x, this will still work. And next on this list, we have the pipe. So here, pipe is also known as the bitwise OR operator. So here I'm going to create 2 binary numbers. So here, if I print the binary of A or B, I'm going to get 1111100. And here we have it. So what's happening here is that in the bitwise OR operator, if there's at least a 1, the result will be a 1. So here in the first 2 bits, both A and B are 1, 1. However, in the third and fourth bit, A is 1, 1 while B is 0, 0. However, due to the OR operator, at least one of them is a 1, so it will be 1, 1. And over here, this is the same, but then B is 1, 1, so this will be 1, 1. And only if both A and B are 0, this will be a 0. And that's why we get 1, 1, 1, 1, 1, 1, 0, 0. And next on this list, we have a semicolon. So here, a semicolon can be used to squeeze multiple lines of code into one line. So x is equals to 1, y is equals to 2, z is equals to 3. So I can print x, y, and z, and they'll function normally. And next on this list, we have our colon. So the colon is probably one of the most important punctuations too. So here we need a colon to write if-else blocks. So if 1 is less than 2 and do something. So we also need to write for loops. So for I in range 5, print 1 to 3. We also need to write while loops. So here while true. We also need to write functions. So define test something and we print something else. And aside from this, we also need to write try except blocks. So try, let's say x is equals to 1 divided by 0 and except. So we print error. So here in both the try and except blocks, we need to have the colon. And next, let's talk about our single and double quotes. So we use them to define our strings. So x is equals to apple, or I can do this, y is equals to apple pie. So here, it doesn't matter whether we use single or double quotes, as long as we start and end with the same one. Next, we can also create this triple quoted strings. So apple, orange, pear, durian, green, z. I'm gonna get this. So here, notice that whatever new lines that we put literally here is printed out. And here we have the less than and more than operator. So if 1 is less than 5, we print. And if 4 is more than 3, we print. So these are simple comparison operators. And here we can also add an equal sign behind to signify that this is a less than or equals. And similarly, this is a more than or equals. And aside from this, we can also have the left and right shifts. So let's say I have x is a binary number, so 0b 11110000. So if I print x left shift by 1, I'm going to shift all the bits leftward by 1 step. So if I print the binary of this thing, I'm going to get an extra 0. So here we have 11110000. So here, if I change this to a right shift, all of the bits is going to shift rightward by one step. So if I run this, I'm going to get 1111 and let's say if I change this to a 3, I'm going to shift all the bits rightward by 3 steps, and I'm going to get 11110. And next we have our comma. So when we define a function, so let's say test a and b, so if we want to define that our function takes in more than one argument, we have to use a comma to separate them. So this aside, when we call functions, so let's say we print apple, comma, orange, comma, pear. So when we call functions and we pass in more than one argument, we must also use commas to separate them. So in lists, in dictionaries, in sets, and in tuples, so in all of these built-in data structures, we must use commas to separate the elements. And next we have the full stop. So here we use full stop mainly to access either a method or an attribute of an object. So let's say x is equals to hello, and we print x.upper. So if we do this, we will get x but in uppercase. So what's happening here is that upper is a built-in method of the string, so we can use dot upper to access this method. And finally on this list we have our question mark. So in Python, the question mark doesn't actually do anything. So once again, thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.